So we clearly say there is a good demarcation, a partial conductor as well as a partial insulator. The highest energy level of the valence band, conduction band, is completely empty. It is filled with, the valence band is filled with abundance of free electrons. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. We start discussing the last chapter mentioned in your syllabus, a very beautiful chapter, what we call as semiconductor electronics. The electronics based on semiconductor devices. So, a very apt chapter to discuss semiconductor electronics. To begin with, whenever I consider an electronic device, understand it is based on the direction of flow of electrons. The operation of any semiconductor device, the performance of a semiconductor device is based on the direction of the flow of electrons. And to be more characteristic, it is based on the unidirectional flow of electrons. So the entire chapter is to understand the behavior, characteristics of semiconductors when electrons move unidirectional in them. Now, let us go back to the ages where people used vacuum tubes, valves, triodes, diodes to operate electronic devices. It was not so easy using these devices because the basic difficulty was to carry them. Two electrodiodes, triode valves, they get heated up easily. The performance is lost due to heating. And therefore, people thought, why don't we use the barriers, the junctions, or the coalescing of semiconductors to perform electronic devices? They started something called semiconductor physics, and today we have reached a stage where we have built the integrated chips, all thanks to something called as a semiconductor. Now, what is a semiconductor? Very clearly, we told semiconductor is a device whose conduction lies between a metal and an insulator. It is a partial conductor as well as a partial insulator. Its resistivity very specifically lies between the resistivity of metals and insulators. And the characteristics of semiconductors are the different energy bands present in them. And these energy bands cause energy variations which will help us to characterize current or voltage in that semiconductor. And therefore, the first thing that we study here is the definition of energy band. You try to understand the entire chapter is theory-based, concept-based, less mathematical relations. Therefore, you have to make an attempt to understand the concepts here very thoroughly. So the very first chapter or the very first concept we understand here is energy band. Now, energy band is a collection of energy levels, what we also call group of energy levels, where there is continuous variation of energy. In a semiconductor, when I refer to a charge carrier, I'll come to these texts very deep next. An electron or a hole, they jump from one band to another, from one energy band to another energy band, causing variation in energy. So a group of energy levels, a collection of energy levels where there is continuous changes in energy, maybe excitation or de-excitation of charges, is what we call as an energy band. So energy band is a collection of energy levels, group of energy levels with continuous variation in energy. Now, the next one is the valence band. So if I characterize the different bands, if I picturize the difference or different bands in a semiconductor, it is exactly like this. I have a valence band. I have a conduction band. And in between valence band and conduction band, we have something called energy gap. So if you understand the band structures of a semiconductor, how different bands are constituted in a semiconductor? You have the valence band, you have something called conduction band, and in between the valence band and the conduction band, you have the energy gap. So what is this valence band? It is the energy band occupied by valence electrons. ಹೆಸರು ಹೇಳ್ತಿದ್ದಂಗೆನೆ valence band. What is present in the valence band? Outermost electrons called valence electrons. So we say a valence band is a residence house for valence electrons, and as clearly shown in the picture, it is present below the conduction band. So the valence band is present below the conduction band. So valence band alli enirutte, it is exclusively for the valence electrons. The valence electrons of an atom will occupy the valence band. And where is it found? It is present below the conduction band. Now, what is the conduction band? It is the energy band occupied by the non-valence electrons, or what we call conduction electrons. Conduction electrons andre, these are the charge carriers responsible for current in a semiconductor. ಮುಂದೆ forward bias, reverse bias ಅಂತ ಓದ್ತೀರಾ. How conduction is possible ಅಂತ ಓದ್ತೀರಾ. You study junction diodes, Zener diodes. We study the characteristics of voltage and current there. So something has to be possible or responsible for conduction. That is what we call conduction electrons, and the conduction electrons always occupy the conduction band. And most importantly, energy gap. It's a very beautiful word where the energy gap is called forbidden region. Forbidden. The electrons are not supposed to enter the energy gap. It is a forbidden region. It is present between the conduction and the valence band. Here, the electrons cannot enter. Therefore, it is called energy gap or forbidden region. Or also we say, it is the difference between maximum energy level of the valence band and minimum energy level of the conduction band. Maximum energy level of the valence band and minimum energy level of the conduction band. And very, very clear, it is an LOC, line of control, forbidden region. Please to understand, the electrons cannot enter into this forbidden region. So we have something called energy band. It is a collection of various energy levels, and these energy levels create continuous energy variation. Valence band occupied by the outermost electrons. Valence electrons, a beautiful residence for valence electrons, and it is present below the conduction band. Conduction band is the energy band occupied by the conduction electrons. In between the valence band and conduction band, there is forbidden region called energy gap. Electrons cannot enter into this energy gap. It is forbidden, or it is the gap between the highest energy level of the valence band and lowest energy level of the conduction band. Now, a very important concept, always asked for 3 marks in the examination: band theory of solids, or classification of solids based on the band theory. ಅತಿ ಮುಖ್ಯವಾದ ಕ್ವೆಶ್ಚನ್ ಇದು. 3 ಮಾರ್ಕಿಗೆ ಯಾವಾಗಲೂ ಕೇಳ್ತಾರೆ ಬ್ಯಾಂಡ್ ಥಿಯರಿ ಆಫ್ ಸಾಲಿಡ್ಸ್ ಅಂತ. So we classify solids based on the band theory. Solids are classified into 3 types. One, what we call as conductors. The second one, insulators. The third one, semiconductors. ಮಕ್ಕಳೇ, ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಪಾಠದಲ್ಲೂ ನೀವು ಮೆಟಲ್ಸ್, ಇನ್ಸುಲೇಟರ್ಸ್, ಸೆಮಿಕಂಡಕ್ಟರ್ಸ್ ಬಗ್ಗೆ ಓದಿದ್ರಿ. ಬಟ್ ದೇರ್ classification was made on their conducting properties, resistivity, resistant properties. If a material allows charges to flow through it, it is a conductor. If it doesn't allow charges to flow through it, it is an insulator. Partial conduction and partial resistance, it is a semiconductor. But here we are classifying solids based on their band theory. Now, what is this? First, what is a conductor? Conductors are solids in which beautifully valence band and conduction band overlap. If you try to understand a conductor, this is the valence band, this is the conduction band. So very clearly here, the valence band and the conduction band overlap each other. Meaning to say, here there is no existence of energy gap. Conductors ಅಲ್ಲಿ ಯಾವ ರೀತಿಯಾದಂಥ ಎನರ್ಜಿ ಗ್ಯಾಪ್ ಇರೋದಿಲ್ಲ. ಸೊ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ there is no energy gap for a conductor, and they are largely filled with free electrons above 0 Kelvin temperature. Conduction, maximum conduction andre it should have free electrons. So conductors are largely filled with free electrons above 0 Kelvin temperature. So what is important here is, when I try to understand a conductor, both the bands overlap. The conduction band is overlapping the valence band. No existence of energy gap. Abundance of free electrons at normal temperature. Next one, insulators. Insulators are solids where very clearly valence band and conduction band are separated by a large energy gap. So according to band theory, this is the valence band, this is the conduction band. There is a large energy gap greater than 3 electron volt. ಒಂದು ಇನ್ಸುಲೇಟರ್ ಕಂಡಕ್ಷನ್ ಪಾಸಿಬಲ್ ಇಲ್ಲ ಅಲ್ಲಿ. So we clearly say there is a good demarcation, good separation between the conduction band and valence band. Clear existence of energy gap in the order of 3 electron volts. And here conduction band is completely empty. Insulators ಅಲ್ಲಿ ಕಂಡಕ್ಷನ್ ಆಗ್ಲಿಕ್ಕೆ ಚಾನ್ಸೇ ಇಲ್ಲ. ಸೊ ಕಂಡಕ್ಷನ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲಿಂದ ಬರುತ್ತೆ? ಸೊ ದಿ ಕಂಡಕ್ಷನ್ ಬ್ಯಾಂಡ್ ಇಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಎಂಟಿ. ದ ಹೌಸ್ for conduction electrons is completely empty. That is what is an insulator. Semiconductors, as we told, partial conduction, partial insulation. It partially behaves as a conductor, partially behaves as an insulator. Therefore, here the valence band and conduction band are separated by a small gap. Semiconductors alle there is an existence of small energy gap less than 3 electron volt. Here conduction band is partially filled. ಯಾಕಂದ್ರೆ partial conduction ಆಗುತ್ತೆ. So conduction band is partially filled with free electrons. So this is how band theory is classifying the solids. Conductors, conduction band and valence band overlap. No existence of energy gap. It is filled with, the valence band is filled with abundance of free electrons. Insulators, large demarcation, clear-cut existence of energy gap greater than 3 electron volts. Conduction band is completely empty. Semiconductor, a small energy gap. The energy gap is less than 3 electron volts. Conduction band is partially filled with electrons. And this is how you can see clear-cut picture showing the nature of conductors, semiconductors and insulators. Semiconductors, no energy gap. You can clearly see that the conduction band and the valence band are overlapping, crossing each other. Insulator, clear-cut demarcation, energy gap greater than 3 electron volts. Conduction band is completely empty. Semiconductors, it is less than 3 electron volts. So we say conductivity of a conductor is 10 power 2 to 10 power 8 Siemens per meter. Semiconductor 10 power 5 to 10 power 6 Siemens per meter. Insulator 10 power minus 11 to 10 power minus 19. No conduction at all. So very beautifully in today's session, we had an outlook to the semiconductor theory. What actually a semiconductor is, what is an energy band, types of energy band, forbidden region, and classification of solids in band theory. The next, we try to understand the classification of semiconductors. Until then, go through the session, understand the concepts. Have a nice day. Thank you.